Okay, so we will start with new subject. Okay, finish the attendance. Okay, I'm going to in the attendance. $100 students, but I cannot see 100 students. Okay. Okay. Write their names. So we will speak about second supervised learning classifier. Which first classifier? Yes. So second one will be KNN. K nearest neighbor. Okay. You know the word, tell me your friends. I will tell you who you are. Yes, it's same issue. We have data set. We have labeled data set. Okay. And we have a new data under a specific category or a specific classification. So to do this, we will know who's the nearest neighbor for this new item. Nearest neighbor. What do you mean by nearest neighbor? Nearest means distant, yes? So it's depend on distant. You remember when we want to represent data using two features. So we will represent it like what? Like this, yes? So we have feature, for example, x1, feature x2. So we have this data here. For example, if we have 1 and 1, we have this data here if we have 1 and 4, for example. 1 from feature X, 4 from feature X2, and so on. Okay, if we have 3 features, then each item, for example, this item will have a point that have 3, what we name it, dimension. Okay, so if we have 3 features, it's become 3D, yes? So feature X1, feature X2, feature X3. So each point will have point X, Y, and Z, or X1, X2, and X3. If we have 4, we cannot imagine it, but each one will be like this, have 4 different. Each one, it's the value for each feature for the specific item. Like this, we represent the data. Now, what about K nearest neighbor? K nearest neighbor, we already have labeled data like this. Then we have a new data. For example, this data in a specific location. How to identify the location depends on the features for this data. For example, if we speak about brightness 5, and if we speak about tall, it's for example 3 centimeter. If we speak about the tall of antenna like that one, it's 2 we identify it's where exactly. So depend on the distance here. Okay, we calculate the distance. Then we have to know it's near to which class more. Okay, which class? Depend on the basic idea, it's like this. Which class? Okay, maybe we have too many data. We have from this class, we have too many data. And from this class, okay. And we have this one. It's the new data. It's belong to this class, O class, or circle class, or X class. Okay, we need to calculate distance between this new data and other data, this first issue, and depend on how many one close to it, how many one, the whole data. From here comes the word K. K, it's number of neighbors that we will calculate the distance between it and Y, or consider it when we classify them. So we have to take like area that have this number of instance or objects. Then how many one from this K number of objects will be in the same area with Y? If, for example, we have this one, this area, we have 1, 2, 3, X, we have 1, 2, 3, 4, 5, O, then Y will be with O. This is the idea. We will take it step by step. So the idea, we have to know how many neighbor we will take. And then we will see this neighbors, this neighbor. So why we need the distance? We said take 5 neighbors. The closest one for it. So 5 closest items or objects for the new object. Then we will see this to which category. If we have 3 to category O and 2 for category X, then the new data will classify into category O because we have more objects. So it's more probably belong to category O. So this is the idea. So look here. Where is, oh, I use the touchpad, not this one. Okay, is it ad hoc? This is the question. So we have data set, labeled training data set. We know that this one duck, for example, this one chick, this one chickens, this one this one goes. I think yes. Okay, so this one, is it a duck? Okay, it's if it's sound quack like a duck, and if it's walk like a duck, then it's a duck, yes? But in computer, we will not know walk like, we know the features, yes? If it's feature, type of walking and sound and so on, or the level of the sound and so on. So these items will be as points. Okay, then this is a new record. It's close to which points? Then how many points from each category close to the new data? The ones that have more points close to the new data, then the new data will be categorized into same category. For example, if we have 3 or 2 data as dark, okay, and we have one data as check and this one here around them, then it's almost most probably is a dark. This is a basic idea, but how to calculate it? We need first of all training data or previous data, previous element. That's why it's supervised learning. Yes. So its name K nearest neighbor. Okay, let's take one by one. K, what's the meaning of K? How many neighbors we will examine it in which category? Yes. So, for example, we have 10 neighbors. We have to identify how many neighbors. Maybe the data set have 100 elements, but we will not examine the 100 element. Why? Because it will take time. Yes. So we should calculate number of neighbors that could help us to categorize the new data. So K means number of eyes. Okay, so we look to similar data in specific category. Let's go directly. We have to about you have data set, I4 and so on, and you have features F1, F2, and you have, for example, the class. So this one, for example, 5, 4, 3, 2, and so on. And this one under category C1, C1, C2. So you have the test data, new item, for example, item X, and its data 3 and 5, for example. So every time you will calculate the data, the distance between the test data and the data set, your training data set. So you will have the distance here. You have to calculate it. If you have JY have 4 and 3, of course you will have different distance. So every testing data will have different distance. Yes, that's why every time you need to get the distance. Okay, so For a given instance T, okay, get the top K dataset instance that are nearest to T. T means the test data. So you have new data, you need to test it. So if we speak about K nearest neighbor, for example, 5 and N. What's the meaning of 5 and N? Means K is 5. So 5, if K equal 5 data set instance means element, yes, in the data set that are nearest to T, the new data. Okay, how to calculate nearest distant? As I told you, it's a distant, yes? It's a distant. We have Euclidean distant, okay? To calculate the distance between 2 points. At the end, it's points, point X and point Y, and how much the distance. How to calculate the distance? For example, point Y, it's have X1, Y1, and this one have X2 and Y2, yes? So X1 minus X2 power 2 plus Y1 minus Y2 power 2, and we take the squared for it, yes? Or square root, squared or square root. Okay, this is the most distant equation. By the way, we have many equations for the distant, yes? So we will calculate the distance between all the data set, the whole training data set. Then we will check the nearest 5. Then this nearest 5, we will check how many categories we have or what categories for these 5 elements. For example, if we found that 3 elements category C1 and 2 elements at category C2, then T will be categorized under C. Yes, because we have more instances. So we will categorize T into the categories that have most instance of the neighbors. Yes. Okay, how many K? How many neighbors we should get for the result? Okay, so for example, we have minus and the plus category here, and we have a new data X. If we take one nearest neighbor, then it's for X will be classified as this nearest neighbor. So as you can see here, X will be classified as minus. Okay, here we take one neighbor. Here we take 2 neighbors. So 2 most and minus. So it could be plus, could be minus. That's why K, it's better to be odd number to avoid the tie, yes, between the categories. Okay, when we take here 3 categories, we have 2 plus, 1 minus, so it's become plus. So as you can see, for K equal 1, it's minus. X become minus. For K equal plus, so number of nearest neighbor will affect the classification. So let's take the whole data, yes? but this makes the algorithm inefficient because it's need more comparison and more calculation. That's why we should know how many K. We will mention how to select number of K. This is the algorithm. So first step, select number of neighbors. Okay, so we should identify K. K usually it's a squared number of elements in the that training set. So if we have 16 training set, it's equal 4, but it's better to take it as 5. If we have, for example, 25, we will take it as 5. If we have 30, it's almost 6, yes, the root, because we will take specific number. So we will take it 6 or 7. It's better to be 7, and so on. It's the simplest way to identify how many K we or which number of we will take the K. So the next step is to calculate the distance. Calculate the Euclidean distance of K number of neighbors. So we have a new element, for example, T. We have to classify it. So we will calculate the distance between T and the whole data set. Then we will take the K nearest neighbors. This is the third step. Among the K nearest neighbor, we will count number of data point in each category. So we will assign point T into neighbors, yes? Then finish. Yeah. Our model is pretty nice data. So it says that it's simple, only calculate distance and so on. So, yes. So it's simple. It's strong or opposite for noisy training data. Okay. It's effective, but I did not say it's efficient. It's effective for large training data set because it will give you almost the correct category, okay, for the new data, but it's not efficient because computation, because you need to calculate the distance every time between the new data point and all the training samples. So it's not efficient. It's effective, but not efficient because it's need calculation time. This is the idea. We have category A, we have category B, then we have a new data. It's belong to category B or category A. Actually, it's depend on K, the value of K. So if we said value of K 4, for example, then you will find that it's almost not to classify. If we take it as 5, maybe, or 7, then it will belong to this one. If we take it as 5, it's belong to this one. If it's 6 or 7, it's belong to this one. So K will make big difference for the result. To check the result, we need to check the distance first. So how to calculate the distance? We have actually many ways to calculate the distance, which I think I wrote it here, okay? So we will take, or we will use this one, the Euclidean distance, okay? So it's xi minus yi square. We have summation here because if we have more than one different data in the point, okay? Where is it? Why it's moved back? Okay. We have squared Euclidean distance. It's same one without the squares. And we have Manhattan distance. It's depend on, instead of take the power, why we take the power than the squared? To avoid the minus. Okay, when we take the distance, maybe if we take the distance between point X and point Y, if we said X minus Y, the distance will be minus, yes? But there is no distance minus. So this one, to avoid the minus, and the power here also to avoid the minus distance. So almost most of the distance equation, it's almost same, but will not give same result here because square and the squares will not give you the same result. Okay, so let's return here. So this is the distance. If we have point B and point A, point B have x2, y2, point A have x1, y1, then the distance between A1 and B1, it's x2 minus x1 power plus y2 minus y1 power under the squared, yes? Okay, so here, if we take k as 5, and we calculate the distance, this one, the most close 5 elements. So the new data will be classified into blue or green. Green, why? Because the most close 5 elements, it's have 3 greens and 2 blue. So we have 3 neighbor from category A, or the green, and 2 neighbors from category B. So it will classify into category A, the ones that have most data. Okay, same issue here, just point by point. So one of the major issue here, how to choose the value of K. Okay. You are laughing, yes? You like this one? It's not mine. Okay, how to choose K? Actually, if you take K as the whole data set, it will be more accurate, yes, but it's expensive because updating the distance matrix every iteration, it will have a high computation. Okay. So how it's affect? As you can see here, we have class A, class B, and the new data here. This one's a new data. Is it class A or class B? If we take K equal 3, we have two rectangle, one star. So the new data will be classified as class B. But if we take K as 7, okay, so the new data have 1, 2, 3 from class B, and 1, 2, 3, 4 from class A. So the new data will be classified as class A. So the number is make a big difference here. We said this one, okay, the rule. X, it's less than, or K, it's less than the square root of N, not more. So I was taking the next odd. I should take the previous odd. So if you have the square root 6, for example, then we will take K as 5. If we have the squares of N, what N? Number of elements in the whole training data set. So if we have, for 1,000 data set, so K must be, or it's better to be how much? Okay, 1,000, I think it's, let's make it 10,000 to make it much easier. Okay. So what's the square root of 10,000? 100. So K must be less than the square root. So we will take it as 99. So it's good to take K equal 99 for 10,000 data set. Yes, and so on. Let's take example. In this example, we have this data set. In the exam, you will have examples like this. Okay, not same, something like this. So we have 3 KNN. What do we mean by 3 KNN? K equal 3. We identify that K equal 3. And here we have the training data set. And this one's a new element that we will classify it. So here in this data set, we have customer names, George, Rachel, Steve, Tom, Annie, and we need to classify John for which class. We have yes and no. This is the two classes. Then first step, what's the first step? After we identify K, what's the second step? Calculate the distance between which one? Between the new data and the training data set, whole data. So between John and George, what's the distance? Each element minus then power 2. This one minus then power 2. This data minus then power 2. Then we take the square. Yes, this is the distance. We have here x, y, z, for example. Then what? x2 minus x1 power 2 plus y2 minus y1 power 2 plus z2 minus z1 power 2 all squared. This is the distance. So here we have 3 features. If we have 4, each feature minus from the testing and the training minus same feature, power 2 plus the second feature, the minus between the second feature, plus the minus between third features, and so on. So each feature consider data or coordination in the point, okay? So for John, we have 37 for the age. So, and here 35. So 35 minus 37, or 37 minus 35, because we have a square here, plus then the income 50 minus 35, or 35 minus 50, doesn't matter because we take square, plus the second feature, which is the number of credit cards, 2 minus 3, or 3 minus 2 square. After you calculate, you take the squares or the root, yes? So here we have 15. We calculate now same, John with Rachel. So 22 minus 37 power 2. 50 minus 50 power 2 plus 2 minus 2 power 2. Okay, so it's, then we take the squares, so it's 15. Then we calculate the distance between John and the seal. Then we calculate the distance between John and Tom. Then we calculate the distance between John and Annie. Okay, K equal 3. So we take the most close 3 neighbor. Here 15, 15, 152, 122, 2, 3. Why 3? K equal 3. So the most close 3 elements in the training set. So it's George, Rachel, and Anne. Okay. Between this 3, what's this category? This no. This one category, yes. This one category, yes. So, yes, we have 2. So we have 1. So John will be classified as yes. Okay? It's easy, yes or no? In which category? Okay. Let's see another example. We have some ingredient here, like apple, bacon, banana, carrot, celery. I affected badly from the Turkish language. I want to pronounce it as G, yes? So, and cheese. Okay, so we have some food here, and we have the features, sweetness, crunchiness. Then we have the class here, which is the food type: fruit, protein, vegetable, protein, and so on. So this is the data, okay? Then this one, the fruit, okay, or this one, this is a protein, and here's a vegetable. So we have a new item here, which is tomato. Okay, so this is a question, yes? Tomato, is it vegetable or fruit? Doesn't matter for me. The most important for me depend on the features. It will be classified under which one, okay? So if it has a seed, must be a fruit, but it's tastes like a vegetable, everyone same. So here, in this example, we have k equal 3. So we need to classify the tomato. It's in this area. So we will take the most 3, okay, or 4 here, neighbors. Then depend on, okay, we have 2 from fruit, 1 from vegetable, 1 from the proteins. Then we will classify it as fruit, but not because it's test or not test, because of the distance. We classify it depend on the distance. Here we take k as 4. Okay, usually we don't take k as 4, but because we avoid to take a 3, because we have 16 elements, so the square root of 16 will be 4. We avoid to take a 3 because it's too little, so we take 4 because we have different data, but usually we will take it as 3 or 5. So we calculate the distance of 4 elements is fruit and 1 vegetable, 1 protein. Okay, next lecture we will take the k-means. It's for clustering. But before we move, let's check previous exam. Okay. And we will try to solve the question. Okay, this last year exam, it's a short exam. As you can see here, we have one theoretical question, explains the concepts of a classification, clustering, write the differences between classification and clustering. This question is a theoretical one. Here, the table below have our data set. We have 2 features, okay? Brightness, saturation. Each row in the table has a class of either red or a blue. Assume the value of k is 5. So we give you the value of k. Usually we give you the value of k. Classify the following new data entry. This is a new data entry. The distance function between the 2 points is defined here. So when we give you the distance function, don't use Euclidean or, okay, if we did not mention using Euclidean. To make it simple calculation, we take this one, Manhattan, yes? So if we mention which one, don't go and use Euclidean. You use the ones that we give to you. Some students don't read the question. Just read, okay, we have data, we need to classify this one, and all this description in trash. If you don't read it, then he will get maybe 0 or something close to 0. So you have to read that question. Okay. Get a paper and try to answer this one. You come to university without papers and pen? How come? Or you feel lazy to get a paper and pen? After you try, I will give you the answer, okay? Just try. Yes, of course. Yes. Write your name on the paper because I will collect it. You are not here to have fun. Because I see that most of you are not trying to solve it. I will share this file with you. You don't need to take, I will share it with the answer. Don't worry. I will share the file with the answer with you. Five, 77, not 100. Five. Five. Okay. Put sign for his bread here. I have one extra here. You didn't try. So Osama, Muaz, and Iyas, and Mariam, yes. Sama, Rashid, Ali, Saleh, Amir, Siddiq, Ahmad, I'll your bread, yes. Not here. You want to want yes. With okay. So it's an absolute vacuum. So ice yes, so you don't I'm like I said. What's your name? I see this but I'm John. Okay, Karim. Karim. What's your name? Carol. I'm John. I'm Hassan. Very poor what's the name? Why? I like him so much, especially on Telegram. It's very happy. Yes, why people target next time I it's not the message out behind when you are, is there other names here for your presence? Just friends. Who is it sounding to I will take name by name. I will continue. So make it easy for me and for you. Who is this? Is it present here? Okay, let's continue. But if I continue, just start with say for instance. Okay. Okay. Just put things around you. What is that? I still have more, so I will continue. Okay, who else? Okay, this consequences will be on people. Okay, so this is the answer. This is a data set, yes, this is the answer. Oh, it's not the question, yes? Okay, sorry, it was another question. This one. This answer, not that one. Let me just let me just so it's a blue, yes?
Yes.
Okay, so Naja, yes. Anna, Ilara, Stadia. I feel dynamics is here. I think the calculation is very clear here. So first step, we just calculate the descent. Okay. So we calculate the descent. We have the new data. Let's write the new data here, which is 50 and just 50. Ooh. Yeah, don't like my head, like this one. Okay, so we have 50 and 65. So we will calculate the descent from each element here. So 50 minus 40 plus, okay, as you can see, you have to use which one? You have to use this one. If you use the ones that have the square and the square, you will get different result, and it's not my business. I will not consider the result. Okay, you have to focus. What we ask you about what? Actually, we put this one to make it much simple to calculate for you. So this is the whole descent. We told you that k it's equal 5, yes. So the most close 5, 1, 2, 3, 4, and 5. So this one red, and we have 4 blue. So the new data will be blue. For you. I will show you the second one. This one actually, this for 5 whys method. Okay. So we have here the, I will send you the file with the answer. I think this one was the answer. I already sent you the files. Okay, it's good. So this third question. By the way, this one, I did not give it now. It's a cell K means next lecture. We will not give a question for it until now. I will tell you if we will. But K means, generally, we have K means. Where is the question? I think here is the answer for the question. Unfortunately, many students have problem with this question. Okay. However, it's the most simple one. Some students did not answer this one correctly. Okay, we finished. We will take last attendance, then we'll go out. Hopefully this time you will not register your friends, 100. Yes, please collect the papers that you answer the question. Everyone give it to the front one. Just keep it here. Oh, I'm still registering here, recording. I will cut all this remain. reciprocal